Okay, so this last part is for just looking at the voltaic cell and actually writing an abbreviated reaction. They're called cell notations, and you see them you see them every now and again, but they're not very difficult. They go alphabetically according to what you're looking at. But there's some details in here that we want to make sure that you guys know. First off, when you write your cell notation, you're always going to start out with the oxidation. So what will happen is, whether you learn it as alphabetical from oxidation to reduction, or you learn it as alphabetical from anode to cathode, no big deal. That's basically what you're doing. You want to list off whatever solid you're using in that cell. That goes first. That would be your anode. Then you're going to list off any solutions. Maybe there are gases. Maybe there are... No, those are really the only two. So you're going to list those off, and you're going to separate these by commas. You can oftentimes put in the concentration for the solution if you know it. And for gases, you might want to put in the pressure if you know that, so in atmospheres or whatever. The double line means that now you're looking at the other half of the cell. So again, you start out with solutions now, because this is the reduction side, or gases. You can again plug in their molarities as well as the pressures. A single line then separates what the solid is that you're using that's acting as the cathode. So the way in which you build your cell is going to dictate what you line up in this cell notation. The very first one that we want to look at is this one here in letter F. You can tell that what we want is a hydrogen gas to hydrogen ion reaction. And notice what this means is we're listing the hydrogen gas to hydrogen ions because in that order we would be releasing 2 electrons. And so in that order we're actually showing off the oxidation. Since hydrogen doesn't have any sort of metallic form, notice that we're selecting platinum as our metal of choice. So the platinum will in fact be the anode, and at the anode, hydrogen gas and hydrogen would exist as this reaction. On the other side, we're now showing the cathode. So again, notice that our cathode is again platinum. We're going to talk about why that is. Because we want our reaction to be of the iron 3, and again, since this is the cathode, we're actually doing some reduction. So we're gaining an electron here. And then it's turning into iron 2. All right. So again, notice we're listing off the ions in the order in which they're reacting. So iron 3 is turning into iron 2. We also did not select iron as our cathode. And we didn't select iron as our cathode for a very simple reason. If you go over to our table of reduction potentials, you can see that iron has, right, a very nice positive voltage for iron 3 turning into positive 2. And then you can also see that we have some other irons, right, such as this one, iron 2 going to iron solid. We want to instigate the correct reaction. And so since our reaction that we're interested in is the iron 2 and iron 3 reaction, if we put in iron solid, we'll actually get a different reaction occurring for our reduction. Okay? And in fact, if we put in iron solid, we would cause this particular reaction to be now the oxidation and force the hydrogen into the reduction. And that's not what we want to do. So the way in which you build your cell, the solutions that you select, the metals that you choose, will then help show the chemicals themselves how they need to be reacting. Okay? So we're going to take a look here. This is the one that we were drawing as the voltaic cell, and you can see that we already did this one. Again, the aluminum solid is going toward the aluminum ions. I know that because in my cell notation I've written aluminum first and then aluminum ions. That again infers that you have 3 electrons coming off of it. So because we're putting oxidation on the left side and because we're going from the metal to the ion, we know that we have to be losing electrons as well. When you look then at your copper 2 to copper, that side needs to be the reduction. And again, reduction means that we need to be gaining some electrons. So we can write them in the exact order they're listed in the cell notation, and then we can add in the various electrons that need to be added. When you write this as a balanced cell reaction, keep in mind you cannot have any of these electrons left over. So again, we're going to look for a common number between 2 and 3. That would be 6. Again, let's multiply by 3, by 3, by 3. And for our 3 turning into a 6, we're going to multiply by 2, by 2, by 2, and then simplify it down as we end up canceling all of the electrons that are present. All right, so you've already seen this reaction from the other video. Let's do one that maybe you haven't seen. And notice here then we're going to again check our reaction is we're being told that the hydrogen ions will be gaining electrons. So hydrogen ions will in fact be our reduction that's occurring. And our cadmium is losing electrons. So the cadmium is going to act as our oxidation. You can see that if we just went ahead and took these 2 reactions and added them together, the electrons are going to cancel, which means that our overall reaction will look like 2 hydrogen ions plus the cadmium metal turning into the cadmium solid, the cadmium ions and the hydrogen gas. All right. That wasn't what the question asked. The question actually asks us to do the cell notation. So since we're doing cell notation, we want the hydrogen ions and the hydrogen gas to be listed. Again, your hydrogen ions would be listed first. We're not told anything about what the solutions are. Let's assume that they are at standard conditions. If they are at standard conditions, every concentration is going to be 1 molar, and every gaseous species is going to be 1 atmosphere. So again, right now we're just assuming standard conditions in order to fill in what the concentrations and pressures are. Okay? Then what we're going to have is our cadmium. So again, cadmium is now going to be oxidized. I'm sorry. What did I just do? Oh, cadmium needs to be on the other side. Got it. So cadmium is going to be oxidized over here. Cadmium will in fact be the metal. So that's going to act as our anode. And then the cadmium ions will act as standard solutions with 1.0 molar, because again, all solutions will be 1 and all gases will be 1 atmosphere. We are missing something, right? You need to finish it off with 1 other metal, and again, you can choose any metal that's just very not reactive. So previously we had used platinum. Another great choice might be gold, and that would then be our cathode.